Hi guys, in this video we are going to discuss the Starters 87 from Codechef. So we'll be discussing the first three problems from Dev 1, that is inversion of subsequences AB plus C and one or all. So let's get started with the very first problem. So the problem states that Chef has a permutation P of length n and he wants to find the number of non-empty subsequences of P which have the same number of inversions as that of P. Now, I hope that you all know what inversions actually mean, but still, if you have a doubt, then I'll try to explain them in brief. So, what inversion actually means is that if you have a permutation or any array for that matter, that is a collection of numbers, and if you have a number x, right, and if there's a number y that is appearing before it, so let's say this is index I, this is index j. So, if I is less than j, and your x is less than y, right, that means these are not sorted per se, right, and this would cause an inversion. So the number of inversion basically is number of pairs of this sorts. I hope that makes sense. So this is what we need to tell them, that from this permutation P, now this permutation P would be having some magnitude of the inversions, right? Now we have to construct subsequences out of this particular permutation, and those subsequences should have the exact same amount of inversions as that of P, right? And since the subsequent number of subsequences could be really large, so we need to print it modulo 998244353. That is the prime number. Yeah. So for example, over here we have this number 1 2 3 4 5, and as you can see that this is a sorted number, right? So the number of inversions over here would be 0. So if we take individual numbers, right, those would be valid subsequences because even they would be having no inversions whatsoever, right? And we can actually take any subarray from here as well, any subarray, any subsequence from here, right? So the total number of subsequence in array is 2 to power 5 or 2 to power n, 5 over here because n is equal to 5 over here. So it's basically 2 to power n. However, one of the subsequences in the in 2 to power n subsequences is empty. We have to ignore that, correct? So we can say that over here any of the subsequence would be valid because any of the subsequences would also have a inversion count equal to 0. Hence we say 2 to the power n minus 1. Over here it's 2 to the power 5 minus 1, that is 31 subsequences. Over here the array which has been given to us is 312465. Now what is the number of inversions over here? The number of inversions is actually 3, right? Now let's check why the number of inversion is 3. So okay, for this one, 3 is appearing before it and is greater than it, right? So one inversion pair is this 3, 1. For 2, 3 is appearing before it and 3 is greater than 2. So 3, 2 is also one inversion pair. So we have already counted 2 inversions pair till now, right? And then we move ahead to 4, then to 6, then to 5. As soon as we come to 5, we realize that we have already crossed 6 and 6 is greater than 5, and hence this is also inversion pair. So if I write this down, then basically 3, 1, 2, 4, 6, 5, right? So in this particular, you can say sequence, so 3, 1 is one inversion pair, right? 3, 2 is another inversion pair, and 6, 5 is another inversion pair. So it has a total of 3 inversion pair. Now let's see what are the possible permutations we can make with it, which has the same number of inversions. So we can make 3, 1, 2, 4, 6, 5. This would also have the same inversion pairs because one inversion would come from 1, 3, one would come from 2, 3, another would come from 6, 5. So the number of inversions would be same. Also 3, 1, 2, 6, 5 is also valid, correct? In total, there are only 2 subsequences that you can form over here. So now comes the point that how can we come up with the number of subsequence, right? So important observation, or the only observation required over here, is that since you cannot increase the number of inversions because technically you're just making you're just making a subsequence, right? So you're not adding any elements in that per se. What you're rather doing is you are removing some of the elements, right? So if you remove some of the elements, their inversion, their contribution to the overall inversion count is gonna decrease, right? So in any way, you can either keep the inversion count same, or you can say that it's gonna decrease it. So in an operation, okay, decrease in an operation, that is removal of an element, of any element. These are two things that can happen. Now, since you cannot decrease the inversion count because you have to keep it same, the only thing you can do is you can keep it same, right? So you can keep the inversion count same. Now when would that happen? So for all those elements that are contributing to the final inversion count, you cannot delete those. So for example, in this particular scenario, 3 was one of the example. 3 was one of the elements, right? That was contributing. 1 was another number. So was 2 was also contributing, right? So 2 is also contributing. 6 and 5 was also contributing. So 6 and 5 are also contributing. Now the only number that actually remains is 4, right? So for 4, what I can say is that I can either include it or exclude it, because deletion of 4 won't actually change the total inversion count, right? So how many ways are there to make this particular permutation? There are only 2 ways. I can either remove 4 or I can keep 4. So that's it. That's it about the question. Similarly, in case of 1, 2, 3, 4, 5, right? We could have said that none of the elements or none of the numbers contribute to the final inversion count. So we can delete or keep any of those numbers. The only difference being that we would have said that okay, 2 to the power 5 would have been the answer. However, over here, the null set or the set which doesn't contain any of those elements need to be ignored. Hence, we'll say 2 to the power 5 minus 1 is the answer. I hope this makes sense. Now let's look at the code, how to solve this. So yeah, here's the code. So what we're going to do is, firstly, let's define two vectors or Boolean vectors, left and right. What they'll denote is that whether a particular element, right? Okay, if they are free from contribution. Okay, what do you mean by they're free from contribution? Whether they are actually a part of any of those inversion pairs, right? So how would we come across that? Like, how would we check that? So we'll start traversing from left to right, and for the current element, if the current element is the maximum amongst all the elements from its left, from the 0th position to the current position, then it won't be contributing, at least from the left side of it, right? So we'll do that. And then we'll say that, okay, let us run from the right side to the current element. And if all the elements to the right of it, correct, all the elements to the right of it are greater than it, then also it won't be contributing, correct? So that is something we'll be doing. After that, what I can say is that if the current element, right, if the current element is not if the current element is not contributing through the left or through the right, cool, that means this element is an element which I can delete or I can keep. So I'll increase my count. Now the only scenario is that if my count or the number of elements that are not contributing is n itself, that is the case that would occur in case of a sorted array. For example, in case of 1, 2, 3, 4, 5, as demonstrated over here. If that is the case, then I need to subtract 1, correct? If that is not the case, then I don't have to subtract 1. So yeah, that's what I've done. So that would give us the correct answer. Let's move on to the next problem. That is AB plus C. Now AB plus C says that you have to find out 3 numbers, A, B and C, which need to be greater than or equal to 1. So they cannot be 0, right? And they have to be smaller than or equal to 10 to the power 6, correct? And once you are able to come up with this numbers, the criteria they should satisfy is that A into B plus C is equal to X, right? Now, can we come up with such a number? Yes, there would be multiple ways of doing it, but what would be an easy way of doing it, right? So what I can say is that, okay, let me just take you. Let's just go through the constraint and let's just write that down in a formula, right? So over here they've specified that the value of X can go up to 10 to the power 12, right? And the value of ABC should be less than or equal to 10 to the power 6. Now, when would be the case that the answer won't exist? So let's say if X is equal to 1, right? Then A into B at minimum would be 1 itself, and C is also 1. So 1 plus 1 would be 2. So I cannot have an answer for 1 itself. So whenever I'll be provided with a value 1, I'll say that it's not possible for me to construct a ABC for that, right? So let's write it over here. So basically we are saying A into B plus C is equal to X, right? So let's try to give it some dummy values. Let's say my A is 1, right? Now what I can do? Now I can say that, okay, my B should be X is equal to A divided by B. And then this would be a floor division. So my C can be X minus floor division of A divided by B. Not A divided by B, but yeah, it has to be. Okay, I messed it up over here. Let's write that again. Okay, so my B is equal to, over here, yeah, my B is equal to X divided by A, correct? Floor division. And since this is a floor division, it is possible that there was some remainder that was excluded. So my C would be equal to x minus x over a into a. This makes sense, right? But now what are the edge cases over here? So one of the edge cases, so yeah, one thing is that since over here I've already said that a is equal to 1. So that means b would actually be equal to x, right? And in that case, the answer would be wrong. So what would because b is equal to x, then c would be equal to x minus x divided by 1 into 1. That would be actually equal to 0. But as soon as c becomes 0, what I can do is that I can ask the b to give me some amount of power, right? So what I can say is that let's reduce b. So I'll say x divided by a minus 1. This technically would become x minus a divided by a, right? This is something I can do. Cool. Or I can say that, okay, I don't want to do this. Like, let's just reduce value of b by 1. Like similarly in this particular logic, so I'm reducing value of b by 1, right? B is equal to b minus 1, and then the value of c can be a itself, right? And the equation would still be the same. You can do the maths if you want to. But what's the other condition that could fail now? The other condition is that we are specifying a as 1, b as x divided by a. Now let's say our x was something like 10 to power 10. So that would mean my b would turn out to be 10 to power 10 divided by 1, right? So for handling such cases, because we cannot exceed any of the number in the triplet from 10 to power 16, right? 10 to power 6, or not 16, but 10 to power 6. Hence we have to make a check over here. So as soon as my number, the number x exceed 10000 or 10 to power 6, in that case, I'll set my a to the maximum possible value, that is 10 to power 6 itself. So let's look at the code, right? So you can say greater than 1000. Anyway, it doesn't matter. So if your n is equal to 1 or your x is equal to 1, in that case the answer does not exist. Else I'll assign a dummy value, or I'll assign the value 1 to a itself. However, now if my n or the x that you have taken, if it was greater than 1000, right? In that case, the thing could turn problematic for me. For example, if now my x is 2000, right? Or 2 is 6, 2 into 10 to the power 6. And I've already said that not 2 is 6, but let's say it was 3 is 6, right? Now I've already said that the a is 1. So technically it would say that, okay, the value of b would be 2 is 6, right? I hope now this makes sense, because if the, not 2 is 6, but yeah, 3 is 6 divided by 3, that is 3 is 6 itself, right? And then even after subtracting, so this would be somewhere in the order of 3 is 6 only. That is actually greater than the given limitation of 1 is 6 or 10 to the power 6, right? So I'll say that, okay, if this is the case, then I'll try to assign the maximum value to a, that is 10 to the power 6. Then the same formula would be applicable for b and c. So b would be n divided by a, and then c would be n minus a into b. Now the special case for c was that if c is equal to 0, then what should I do? If that is the case, then I'll assign the value of a to c, and I'll decrement b. That would basically mean that since we were doing a into b, right? So the contribution of this particular term was a into b. Now since I'm doing b minus 1 over here, so the contribution decreases by a, and this contribution would now come from the other term, that is c. Cool. Then I print all the three numbers. So yeah, this is the code for a, b plus c. Let's move to the last problems that we're going to solve today. That is one or all. Now this is an interesting problem. It is related to the standard NIM problem, but the way I've solved it is a bit different. You can remove actually all of this code. This was just for testing, and okay. So yeah, this much code was sufficient for this problem. So basically what the problem states is that Chef and Chefina are playing a game. In the game, there are n piles, and from each of the pile you can either remove a certain stone, or what you can do is that you can remove one stone from every pile. So from any pile you can either remove a stone, or from every pile you can either remove a stone. But this particular condition that from every pile you can remove a stone would only hold if all the n piles, right, where n is the initial number of piles you are having, if all the n piles have at least one stone, then you can perform the type 2 operation. else type 1 operation can be performed till the time you have even a single stone left in any of the piles. Another point is that whosoever makes the last move actually wins the game, right? So how would we solve it? Now it's obvious, like if the number, okay, let's get back over here. Cool. Now if it was a single pile, right? Let's say this was a single pile, or let's say these are the stones I was having, and in each move I could have removed one stone only. Then in that case the answer would have been simple. If the number of stones would be odd, right, then I would have said that chef would win or the player 1 would win. Let's just say A and B. So player A would win. If the number of stones would have been even, in that case player B would win. Now what happens if you give multiple piles and the opportunity to a player to remove stones from each of the piles, or one stone from each of the piles? What actually happens is, now in this particular case, not in this case, let's just remove one pile. Yeah, cool. In this particular case, he could have removed one pile and reduced the sum by -1, right? However, now in this particular case, if he removes one pile from each, one stone from each of the piles, in that case, he does sum -2, right? He decreases 2 stones out of the entire sum. Now this changes the scenario. This gives the player extra power to determine or to change the states that he's gonna move to, right? Earlier in the single pile, he was saying that, okay, I can only go from sum to sum -1. Now the player is also able to go from sum to sum -n, where n is the number of piles. However, this particular condition of going to sum -n would only hold till the time all the n piles have at least one stone, right? Now, should a player use this particular operation or not? Now, we already know what the condition is, right? But should a player even use this particular operation? That would actually depend. Now, let's say you are a player A, right? And your sum modulus 2 is becoming 0. That would basically mean you are at a losing state. So sum modulus 2 becoming 0 would actually be like you're having 2 stones in total. So if you remove one stone, the other player would get a single stone and he will remove it and win, right? So if your sum modulus 2 is becoming 0, in that case, you might think to use this particular operation, right? Now, how would it benefit you? So it would benefit, now let's say if your number of piles is even, right? If a number of piles are even, and from each of the pile you're removing one stone, then technically you are removing even number of stones from that, right? Now your sum modulus 2 or sum minus n, where n is the number of stones you removed since you were removing one stone from each pile, sum minus n mod 2 would also be equal to 0, right? And this is the and sum minus n would be the thing that you would be giving to your opponent. As soon as your opponent has sum minus n, which is technically an even number, right? He's at a losing position. Yes, he can make some moves. He can use this particular move to actually win. But currently, directly viewing via the first type of operations, he's at a losing position, right? So then he'll have to think that should he employ this particular operation or not. Cool. So this is the entire thing that you had to see in this particular problem. So firstly, you could have said that if my sum mod 2 holds, right? So if my sum initially given is a odd number, in that chef can manipulate. So chef already knows that if the current pile, right, if the current total sum is going to be odd for me, then chef can manipulate that, right? Because chef has the capability of saying that I'm gonna either choose the entire piles or I'm gonna choose a single stone itself, right? So because chef moves first, right? So if sum mod 2, then I can directly say that chef is the winner. However, if my sum minus n mod 2 is equal to 0, right? This basically means if chef tries to remove the smallest number, right? The smallest number from all of the not the smallest numbers, yeah, but if the chef tries to remove one stone from all of the piles, in that case the sum should turn out to be 0. But the problem is, now it shouldn't be the case that even the opponent is able to do all of those operations, so he would be able to counter him. So basically the thing would turn out to be that chef would do a sum minus n, right, mod 2 equal to 0, and the opponent would get this sum. Let's say this becomes s2 and the opponent gets it. Now the opponent does the same, so he also subtracted, right, and he sends it back to chef, correct? Now chef also does it, right? Okay, let's call this S3. So chef also does the same, S3 minus n mod 2, right? It sends it back to the player B or the Chefina. So Chefina also does the same. So let's call this S4. So she also does the same, S4 minus n mod 2, right? Okay, the problem with this particular approach is that this would actually halt at a place, right? Now the player at which it would halt at would be the winner, right? So that is what something we want to ensure, that chef would always be the one to make the winning call, right? So that would only occur if this particular mn. Now what is mn? Mn is basically the number of stones in the smallest pile. Now because the condition explicitly said that okay, over here it actually says that you can remove one stone from all the piles. This move can be only done if all the n piles contain at least one stone, right? So the maximum number of times you can actually use this particular operation is order of mn itself, or the number of stones in the minimum pile itself, because once you perform the type 2 operation, one stone gets removed from all the piles, and the pile which is having the smallest operation would also get reduced by 1. So it's only possible to perform this type 2 operation at max as mn times, right? Now if this particular number is odd, that means the criteria we discussed over here, that it will go from chef to chefina and they'll keep performing this type 2 operation. This operation, or you can say chef would be the last one to perform this kind of operation, right? So if this holds, the answer is chef, else the answer is chefina. I hope this made sense, right? I generally find like game theory problems to be a bit tough to explain, but I really hope you were able to understand it. If you still have any doubts, you can let me know in the comment section below. Cool guys, thanks a lot for watching this video. Bye bye.